Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by HCL Software. My name is Cody, and welcome back to Techstrong Learning. We've got an exciting presentation ahead, but before we get things started, I do have just a couple of housekeeping notes I'd like to review. First of all, today's session is being recorded. So if you miss any of our discussion, if you'd like to rewatch, or if you'd like to share with your team, you will be receiving an email with a link to access the recording on demand, and you'll get that shortly after we conclude this live session today. If you'd like to engage with us, there are a couple options to do so. The first and the easiest option is the chat tab. So if you see that chat tab on the right side of your screen, I'd like you to let us know from where in the world you are joining us. Now, directly to the right of that chat tab, you'll see where it says Q&A. Feel free to send in any questions that you have for us today to that Q&A section. We've got some time set aside at the end of our program today to address those, so be sure to send them in. Additionally, if you jump to that handouts tab, you'll see there's not only just a version of these slides available for download, but there are a couple of additional resources there, so feel free to grab those. And before we close things out, I am giving away 4 $25 Amazon gift cards, so be sure to stick around to see if you're one of our lucky winners today. So our topic is improve software quality with application governance. And I'm joined today by Jonathan Harding, Senior Product Manager for the HCL Accelerate team at HCL Software. And we're also joined today by Suren Kumar, Senior Product Manager for the HCL Launch team at HCL Software. So Jonathan and Suren, thank you both so much for joining us today at Techstrong Learning. Jonathan, do you want to go ahead and get us rolling into these slides?
Sure thing. Thanks, Cody. I appreciate the intro. And hopefully maybe I qualify for one of those Amazon gift cards. That sounds pretty cool. But today, yeah, go ahead, Cody. Oh, we'll see, you said. So today we're going to talk about automated application governance, or more precisely, how application compliance, software quality, security, and employee happiness are all interrelated. So as Cody said, my name is Jonathan Harding, and I am a product manager for HCL Accelerate, which is a value stream management product we're going to talk about a little bit later. But first, wanted to talk more specifically about governance, compliance, and compliance controls, which is, I know, is a super exciting topic, but hopefully we can make it worth your while. So first and foremost, a little bit about myself and my colleague Suren that is joining me today. We are part of the HCL Software DevOps team. Although this is a largely remote team, we do have offices that are based in Cleveland, in Rome, and in Bangalore. So we are very much a follow the sun organization. I have a master's in IT from the University of North Carolina in Charlotte, and I have a background in banking, energy, federal government, and big technology. Suren, do you want to introduce yourself?
Yes, John. Thanks for that intro, John. Hi, everyone. My name is Suren Kumar. I'm the Senior Product Manager for HCL Launch. I've got my master's in computer application from Annamalai University. Previous to this, I started my career working for the data center solutions and enterprise servers and storage solutions. During my tenure, I was fortunate to file patents. So I've got 40 plus US patent filed on my name. So currently I'm working for HCL Launch. So that's pretty much about myself, John. Over to you. Bye.
Great. Thanks, Suren. So first, I want to start with a little bit of a story. So I am based in Charlotte, North Carolina. I have lived here for the last 20 years. And what's interesting about Charlotte, North Carolina is it is Banktown, USA. It is the #2 center for commercial banking in the United States, behind only New York City. And if you look at the skyline of Charlotte, the most prominent features you're going to see are banking headquarter buildings. So we've got a huge location for Wells Fargo, Bank of America global headquarters are here, and Truist, which is considered a super regional. It is one of the top 10 banks in the United States. I've spent time working at 2 out of these 3 banks. And one of the things that I noticed in my 15 years working in banking is that as I transitioned from one organization to another, what I learned at the first organization as what I thought were regulatory controls and IT best practices really seemed to be more subjectively applied within those different organizations. And I sort of grew the bad habit of asking, why? Why are we doing it this way? Show me the regulation. Show me where it says we have to do it this way. It reminds me of a story. When I was DevOps team lead for an online banking group for one of these banks, was talking to an information security specialist about how our application development team needed access to production logs so that they could help troubleshoot a problem. And the answer was, no, you can't have access. That violates the principle of least privileged access. It's a regulatory requirement. And it just seemed like that was the end of the story. And so often working in DevOps, what you'll find is people throw up their hands and say, we can't do it. We can't do it that way because we are a highly regulated organization. And what I want to sort of talk through today is, what does that actually mean? Where might we be confused? And is there a way that we can sort of push the envelope a little bit more with the way in which we approach Agile and DevOps to help counter some of the things that might be holding us back? So first, that observation I just said, often there are, within IT corporate compliance, there are regulatory requirements that exist, whether it's related to Basel, Sarbanes-Oxley, GDPR, PCI compliance, HIPAA, you name it. There's many both government and industry consortium regulations that exist, and there are ways in which you can comply with those regulations. And then within each organization, they have their own interpretation. They take IT best practices, their own corporate culture, and their own risk tolerance within their organization. And they apply it to those regulatory requirements, oftentimes to come up with their own set of rules. And often there's overlap and there's rationale and why it is this way, and sometimes there isn't. And there's opportunity in this space as us in the Agile and DevOps community know and learn from each other. There's ways that we could do things better and still be within the letter of the law as it relates to regulation. And then on the right-hand side of the screen, of course, we always face audit as well. So it's one thing to say you are complying with regulatory requirements. It's another thing to actually pass an audit. So hopefully what we are going to show you today is how you can apply best practices with current tool sets and technologies and actually pass various types of audits. So first, definitions. What exactly are we talking about when we talk about GRC, or governance, risk, and compliance? The first to define is, what exactly is risk? Well, it's something that happens to your business that's unforeseen, and it comes in many shapes and forms. And just some examples of these that can happen are market risk, right? Perhaps as a publicly traded company, or the overall market, stock market that you exist with, there can be varying fluctuations. Currency markets, cryptocurrency markets, your business may be subject to a lot of these risks. Operational risk. As IT practitioners, we've all told the story of, yeah, but what if an airplane engine hits the data center and takes it out? Those are the sort of operational risks we're looking to sort of anticipate and plan for. Reputational risk. Can anybody say Anheuser-Busch? There are certain things that happen within business that can have a big, negative or maybe positive impact, but within your organization. Cybersecurity risk. Keeping data secure, systems compliant with cybersecurity requirements. Secure engineering framework practices as you are developing new applications need to comply with cybersecurity. And finally, what we want to zero in on today, which is regulatory risk. Okay, that's risk. So then what is governance? Well, you can see it's the setting of expectations, facilitating expectations, and managing risk aligning with expectations. More precisely, it's how a business management chooses to control for or to actually manage the risks that they can anticipate. Compliance is the actual process of documenting and reporting on how an organization complies and meets the governance expectation. When you don't meet it, how are you going to fix it? And then finally, the types of controls that you can have in place. governance uses controls to actually mitigate risks. So there are detective controls for risks that have already happened, corrective controls to repair processes that are broken, and then preventative controls, which make risks less likely. So moving on, if you look across the spectrum of different types of regulation, generally the requirements to comply with those regulations fit into any of these 6 buckets. And I know you're looking at the picture on the left-hand side that says no jumping off the bridge. And if you're like me, when you're facing people saying, no, you can't do that because it's a regulatory requirement or a regulatory control, you might want to jump off a bridge. But hopefully with what we learned today, we could prevent that from happening. But the first category is around data privacy. This is a big one. PII, or personal information, personally identifiable information. And data privacy is how that data is handled, processed, and stored within your IT systems. Overall process, making sure that your software development lifecycle, your IT processes adhere to defined IT process requirements, goals, and desired outcomes. Overall cybersecurity, ensuring that infrastructure, systems, network components, applications, all those practices related to information system security, keep those systems secure. Functional requirements that must exist within the applications that you are creating. So this is things like disclosures and other notifications to your users, and a variety of other different types of functional requirements that must exist. Roles in certain regulations require that there's a person within your company that actually is responsible for ensuring that your company adheres to that regulation. And then finally, overall IT configuration, ensuring that you're using common sense things like, firewalls, network controls, not using default system configurations and default passwords and things like that. So typically, and all the regulations that you're going to encounter, must comply with things that fit in these buckets. So let's look at some of the major regulations that exist and that we all need to comply with, just to get an overall idea. So the first is Sarbanes-Oxley. SOX came about in 2002 through US federal legislation. It came about because of largely the Enron scandal. Enron at the time in 2001, 2002 was the 5th largest publicly traded company in the United States. It had a huge hold over the energy industry, and it did some unfortunate side effects like major blackouts in California. The regulator for SOX compliance is the Securities and Exchange Commission, and it covers IT processes that are related to financial reporting systems and data. But typically, publicly traded companies that must comply with SOX apply these practices across all of their applications, not just those that are financially related. And of note, it's actually written into SOX that organizations must have an IT change management process. So think, change control and request for change. And it also mandates that there's a separation of duties for financial applications. So within the DevOps world, this means, of course, that team members that developed an application can't be the ones that deployed it into a production environment. But we're going to talk about how there might be ways in which we can comply and still implement best practices. The next one is GDPR. GDPR largely relates to, which is a European regulation, largely relates to data privacy, technical features that are required within applications, and incident reporting if your organization has been hacked or if there's been a data breach of some sort. What's interesting here is there's no single regulator for GDPR. It's actually required that each EU member state or member country has their own regulatory body. Interesting fact about GDPR, between Amazon, Google, and Meta, they've paid $1 billion collectively in GDPR fines. Huge amount of money. The fines for GDPR violations are huge, and in some cases directly relate to the amount of revenue that a company brings in. One other thing of note, you'll notice there's one large tech company that's missing from that list. And it just so happens that HCL Software, Unica, which is our marketing software platform, is in use by that particular company, which I shall not mention. The next one is HIPAA. This is related to PHI, personal health information. What does it cover? Data privacy. PHI must be protected. I think that just makes sense, and we can all agree. There are required technical features within applications that are covered by HIPAA compliance, and also incident reporting. So again, if your organization has been hacked or there's a data breach, you must disclose that to the regulator. In this case, it's the United States Health and Human Services. Interesting things of note, HIPAA protects personal health information for 50 years, even after a person's death. And it's so broad, it even covers things like license plate numbers. So we've talked about, sort of some of the regulations, and let's talk about what are some of the IT guiding principles and best practices that sometimes get confused with regulatory requirements. The first is segregation of duties or separation of duties, which is a requirement that more than one person be involved in completing a particular task. This makes sense in a lot of cases. It's an administrative control, and it can prevent fraud, sabotage, theft, and misuse of information. The second is principle of least privilege. This is basically a security architecture or a security requirement that says you should only provide the level of access to a user that's required for them to do their job. The next is need to know data management. And this is an overall strategy that organizations implement that basically limits the amount of information that employees have access to, so that they only have access to sensitive information when it's required to do their job. So similar to principle of least privilege access, but this applies to data in general. And then finally, granular role-based access controls, RBAC. We're all familiar with how the systems that we use on a day-to-day basis each have their own implementation of role-based access controls. And generally, these access controls comply or they match a functional role that exists within an organization. So in the software development space, you might have a software role, a QA role, et cetera, et cetera. And oftentimes, this RBAC can be overly restrictive in preventing people from getting their job done. So finally, talking about audit. So, you have to prove, if you are in a highly regulated industry, that you are complying with audit controls. But what's confusing is there are different types of audits that you often need to work with. Sometimes you don't even know what type of audit. You just know that someone has come in or someone's coming in next week, and you have to sit down and walk through their audit process to explain yourself and make sure that your team or your application is in compliance. The first is internal audits, typically for publicly traded companies. Internal audit teams exist, and they often will go out and make a selection of applications or teams that they will audit on an annual basis. The employees for those internal audit teams are within the same company. So they are often within a separate department, so that they are not influenced by politics or culture of that particular part of the organization. The second is external audits. This is also required for publicly traded companies to have third-party auditors. Think of the Big Four, the Big Five, CPA firms. They are, classic examples of companies that would come in and perform an external audit, including IT audits. And then finally, regulatory audits. Often the regulators themselves working in banking, we often referenced and had to work with the OCC, the Office of the Comptroller of Currency. They would sometimes come in and want to have a look at and talk to members of the application teams for our most sensitive and most critical applications. This was particularly true after the financial crisis in 2008. Where it became very clear the systemic risk that banks posed to the overall economy. So finally, bottom line point is that regulation, audits, and IT best practices are confusing. It's often conflated, a lot of the requirements, a lot of these best practices. And this is what leads to what I've always been taught when dealing with auditors and audits within my various roles, which is you speak when spoken to when you're going through an audit. You only ask exactly the questions which are that the auditors are asking of you. You give no extra information because it poses a risk that you might fail that audit. And what the point I want to make today is that it doesn't have to be this way. We actually have an architectural pattern that applies to DevOps, Agile, and software delivery that is proven to work and that can actually survive different audits. And that's what we want to demonstrate here today. So, as I said, there is a proven multi-stage model, and HCL software DevOps using AppScan, Launch, and Accelerate can help you implement that model and achieve those regulatory controls. So the first thing to briefly walk through is source code control. And the way that I wanted to lay things out within this particular slide is you can see on the right-hand side some of the typical actions that you would take interacting with a version control system. And on the left-hand side, some of the controls that you can put in place. And the icons represent the different types of controls, which would qualify as a best practice, and those which would qualify as a regulatory control. So first, what are some of the risks when users are interacting with version control systems? Well, the first is unapproved or untraceable changes. You want to ensure that all of the software code that's being written and committed into your version control systems actually correlates to an actual requirement or a software defect that someone is working on. Second is vulnerable dependencies. We all know that third-party dependencies, free and open source, commercial dependencies are part of all of the products that we're working on a daily basis. And you need to keep tabs on those that software supply chain to ensure that you have no vulnerabilities within the software supply chain of your product. The third is leakage of personal information or personal health information. And then finally, overall low quality code. You want to make sure that what's being committed into version control system is the highest quality code that you can possibly achieve, so that you can keep defects out of production and you can ship left. So moving on to the next one, continuous integration. So sort of the second thing that I wanted to talk about. Again, sort of same format. In this case, we're going a little bit from left to right. So on the left-hand side, we have the trigger of when a new build is actually created as part of your CI process, and the output on the right-hand side. Same format. The best practices are denoted with the lock and the regulatory controls by the shield and lock. So what are some of the risks that you encounter in continuous integration? Well, the first, again, is vulnerable dependencies. Why are we talking about it again? Because there's another layer of protection that you can apply within your overall software delivery process. And as part of your scan phase within CI, you can actually do a software composition analysis scan, or even scan an overall container. So if you have a container that's deployed with a base image, which you might have gotten from a public repository, and then overlaid your own application within that container, of course, you want to ensure that everything inside of there is safe. The second risk is the integrity of software packages. It's critical that when you are creating new builds, new potential release candidates, that you are storing those builds in a secure location and that you have a retention policy so that you can retain those artifacts in the event that at a later date, depending on your industry, depending on the regulation that you need to comply with, you have a copy of those artifacts going back in time so that you can show that chain of custody to your regulator. The third thing is insecure code. And there's various controls for insecure code. I'd say the most prominent is what's called a SAST scan, and this is available in the HCL software AppScan product. A SAST scan, similar to a static analysis scan, is actually going to look at your code that your team is producing. Instead of looking for different quality characteristics, SAST is specifically looking at software security potential vulnerabilities. The fourth, insecure build configuration. So you need to ensure that the build scripts are treated like code, like everything else, and that those are stored in version control, and that those go through the same practices as a normal code change. Association with a requirement, peer review by one or more people, etc. And then finally, improper dependency licensing. So this is sort of a variation on software composition, but there are dozens and dozens of different open source licenses that exist out there. It's a best practice to ensure that the licenses that you're using within your build process or that within your software supply chain for your technology product comply with what your company says is okay. Okay, moving on to the last section, which is continuous delivery, the actual automated deployment into non-production or LLEs or lower level environments, and then also the deployment of that release candidate into a production environment. So what are some of the risks? First, untrusted artifact source. Again, this goes back to secure storage. At the end of your CI process, when your build is complete and your artifacts are created, they're stored in a safe place. That has to be the only place from which you deploy code, your applications, your containers, and your infrastructure as code. The second is unapproved network configuration. You need to have controls and scans around the way in which both your lower level systems and your production systems are configured to allow ingress, egress, and different firewall controls within those systems. Testing with production data. So if your application is regulated, it likely has sensitive data within it. It's obviously not a best practice, and it's a regulatory violation to use that type of personal information within testing environments. So, products like HCL OneTest allow for the creation of testing data, which can exercise your application and ensure that your application works with the data set that you need it to, but doesn't use personal information or actual personal health information of your customers. The lack of quality gates in non-production. You need to ensure that, quite simply, testing is incorporated into your overall deployment workflow to make sure that you're properly exercising your application in non-prod environments before it goes to production. Lack of vulnerability detection. So particularly in production, but in non-production as well, you need to have ongoing threat monitoring to make sure that your systems have not been breached or hacked in any way. Unauthorized changes. Again, back to the beginning of the pipeline when we talked about source code control, ensuring that all changes within your system, including system level configuration, are maintained in version control and controlled just like any other piece of source code. And then finally, unauthorized access. If you are using configuration as code, your application, your containers are all deployed using a CI/CD system, there should be minimal or no access required within both your lower level and production systems. So you do need to have a production break glass process in place in the event that there's some unforeseen thing, defect or issue that you need to remediate. So moving on, what I wanted to show with my colleague Surin is a couple of examples in how HCL Accelerate and HCL Launch can actually help your organizations comply with some of the framework requirements that I've just laid out. So first, I want to show the HCL Accelerate application, which is a web-based value stream management system that largely is targeted at making teams more efficient, as well as helping to implement the instrumentation of CI/CD using quality and compliance data. So just a brief description of what we're looking at right now. This is the core view within HCL Accelerate. It's the value stream view that helps visualize work that's in process. So think about a typical sprint team, between 5 and 15 people, working in sprints, be it 10 business days, 15, 20, however long your sprint duration is. This shows all of the work that they have in flight, and it shows a synergy or a combination of data from multiple systems, not just issue tracking systems, but also version control, dependency management, CI/CD systems, application, automated testing, static scanning, you name it. We've got 50 different plugins for a variety of different systems that basically add context and information when you are visualizing this work that's in flight. This can be a great tool for Scrum Masters, product owners, product managers to really have a high level of awareness of exactly where work is that's in progress, and also the quality of work that's being produced. But what I actually wanted to zero in on specifically as it relates to the framework that we just looked at is our pipeline view within the application. So in this example case, I have a CI/CD pipeline that's been instrumented in different types of systems. So in this case, I have a web-based application called HCL Commerce Store. That's an example furniture application, furniture e-commerce site. And this site is a Node.js NPM application that's maintained in GitHub, and the CI process is all executed within GitHub Actions. And the deployment of this system is done using HCL Launch. So what I wanted to demonstrate here is that, as a DevOps engineer, I have access to see all of my, the critical facts about my application, what release candidates are actually deployed in each location. I could also deploy these applications if I wanted to from this interface. This is very useful, especially if your team uses different CI/CD systems within a single team. If you have Jenkins and Urban Code Deploy and GitHub Actions or Circle CI, you name it, you can basically show and integrate all of those systems together in a single screen. But most importantly, as we talked about controls, you can actually put automated controls on top of your CI/CD system to help you comply with your regulatory controls that are needed. So in this case, I could take any of the value stream data that's pulled into the system and made visible within the value stream view. I can actually create rule sets and apply those rules against my CI/CD system. So in this case, what I wanted to show is that in order to prove separation of duties, which is required for SOX compliance, you can actually require that for every code change included in a particular build or a particular release candidate, you must have at least one peer review that's taken place for that application. So we pull in that information, those peer review occurrences from the different upstream systems, in this case, GitHub, and we can create rules that are applied and ensure that those builds that are being deployed into those environments comply with the need to have peer reviews taking place. You can also implement continuous delivery. So if you have a model within your team that says every time a new build is created from our CI/CD system, I want to deploy it into my dev or subsequently higher level environments like QA, UAT, performance testing. You can automate and automatically promote those builds when they've met those compliance criteria and when they've passed all the automated testing that may exist in the prior environment that it was run in. And you can go so far as to implement compliance checks in your production environment, including the existence of a required request for change or change control, so that this can allow you, even in a highly regulated environment, to implement continuous delivery or even continuous deployment. I can't tell you how many times over the past 10 years I've been at DevOps conferences listening to the likes of Amazon, Google, and others like Ancestry.com or Intuit saying, we deploy dozens of times per day, and thinking to myself, that's just not possible within my banking and finance environment because of the strict controls around changes. And what I'm telling you is that you can implement that high frequency of change and still be in a regulated environment and comply and prove to your auditors that you are living up to the letter of the law and the requirements of those regulations. So with that, I am going to hand it over to my colleague, Surin. If you could demonstrate some of the other things that we have in HCL Launch that can help teams comply with regulatory constraints.
Yep. Thanks, John. Can you confirm is my screen visible?
Yep. Looks good.
Yeah. Okay. So thanks, John, for the detailed walkthrough on the process. So hello, everyone. I'm excited to demo the application deployment process in HCL Launch, focusing on governance and security policies that John was talking about. In today's software development world, security governance and the security and governance in CI/CD pipeline is very crucial, as they all wants to increase the pace of the software delivery. Right. Often we see CI/CD pipelines tools are integrated with various third-party tools that cause additional concerns, security concerns in the system. Right. So launch is a solution that prioritize the security during the deployment and minimize the dependency of the external tool. Like John was telling, so HCL Launch is having integration with HCL AppScan that basically ensures your security of your application. Likewise, HCL Launch is having a integration with test automation tools like HCL One Test. Basically, with all these integrations, Launch guarantees that only the thoroughly tested softwares are promoted as your release candidate. Right. So the release candidates gets promoted only if it is thoroughly tested and validated. And that release candidate gets deployed to your production environment and things like that. Right. So these products, like whatever we are displaying, are all part of same family product, same portfolio product. So it minimizes the dependencies of external tools. Right. So, all right. So let me move to the demo content. For this demo, what I have done is I've copied the container, source artifacts into the Git repository. So launch is the continuous delivery tool that is right now there on your screen. Will pull the artifacts securely from the Git repository and build the container and deploy it in your Kubernetes environment with all the security gates and measures that John was showing just before this demo. Right. So this is my GitHub repository, and this is my container, configuration file. And this is my Kubernetes environment. And as you can see, there is no container currently running in the setup. Right. So launch now, how it typically works is in any enterprise applications, right? It will have multiple components, right? Your DB component, your UI component, your middleware component, and all that, right? So basically, you have to go and create components for each of this, application component. And so if you get into this application component, right, so you will have an option to give the source repository from where the artifacts has to be downloaded. So like I mentioned, this is the Git repository I have given for this component. Right. So moving back to the versions, as you can see, right, like as John was saying, whenever any commit happens on the GitHub, right, the launch pulls that latest greatest version automatically and keep that build available for the deployment. Right. So these are the secured artifacts that got pulled from your GitHub repository. Right. So likewise, I've got a couple of other components created. On all these components are tagged to the application the application name called demo my cloud app, right? So if you go under the component session, you can see all the components that that I showed in the previous tab, right? All the components I mapped, right? So if you and we are all set. So if you want to start the deployment for your application, so just by clicking request process here, your deployment gets started. But like John was saying, this deployment can be even triggered from your VSM console also. Like, because for the demo purpose, I'm showing it here. But even this operation can be performed from your VSM console, that is Accelerate. All these products are tightly coupled products, integrated product. So I'm requesting the demo here. Sorry, I'm going requesting the deployment here. So and one thing that to be noted here is that a snapshot. Snapshots are you can consider them as your release candidate. The build which are tested, scanned, and all the security governance policies, that all that is met, and those builds are available for you to create the snapshot. Okay, so basically snapshots are your release candidate, right? So when you select this whichever snapshot, basically you are deploying that version, right? With all the components, you're deploying that version. And also you can see we do have a deployment scheduling option. Based on your release cycle, you can schedule your deployment, and you can completely automate this process. So basically it pulls the content from your Git repository. It pulls all the artifacts from your Git repository, and it deploys to the agents by having this schedule in place, right? So I'm initiating this deployment. So as you can see, currently there is no containers running in the Kubernetes environment. But at the end of this deployment process, you will be able to see the container deployed. And you can also see what are the process happening. So basically it's downloading the artifacts from your Git repository and creating the Docker image, and that Docker image is getting deployed to your Kubernetes environment. All this process are automated, right? So, and also like what John was saying, there are multiple external approval process that we can add to this CI/CD pipeline based on the need of your environment, right? So the deployment is completed. You can see deployment is successful. And if you go to the Kubernetes environment, you can see that the new containers are deployed, right? So if I just one moment, I will just start the container. So we deployed 11.0 version, right? So this is a demo page that I created with 11.0 version. So that got deployed. So this is how you can do your application deployment process with all the security and governance policies in place. That's all I had for the demo, John, and handing over to you back for the remaining slides. John?
Yeah. Oh, sorry. Let me unmute.
Okay.
Can you hear me okay?
Yeah, I can hear you.
Okay, good. Okay, so that was just a quick demonstration of the three phases of software delivery, largely under the umbrella of DevOps, and some of the ways in which HCL Accelerate and HCL Launch can actually help you comply with those requirements that we walked through. But that's great. But everything that we've talked about so far about regulation and audit and IT best practice and least privilege access and all of these things are so difficult and frustrating to deal with on a daily basis. I've heard it referred to as the audit tax, right? And quite frankly, I entered the banking industry because of the audit tax. My first job was as a deployment engineer of a very large derivatives trading platform within a bank. And the reason it existed was for SOX compliance. I couldn't be a developer. I had expertise in large systems and the technologies that were required. So I was a deployment engineer in 2005. Shortly after the creation of SOX. Luckily, that role evolved into what we now call responsibilities under DevOps, and it's much more of a value-added exercise or value-added group within every enterprise. But again, that audit tax can be frustrating. Why do we need to invest so much time, energy, and resources in compliance with audit and regulation? And the point I want to make is that through automation that we've just demonstrated, and some of the practices that that regulation requires, such as peer review of code changes that are going into production, you can actually have significant benefits for your system, for your organization, and for your team. And these are just a couple of examples. And if you're interested in more reading on this regard, I have more additional reading and sources at the end of this presentation, which is available from the webinar portal. But the first is it's much less expensive to find software defects through a peer review process. There was a study done in the 1980s that involved some IBM software development teams that showed that the testing effort required when proper and thorough peer review was done was reduced by a factor of 85%. And of course, finding bugs earlier, before they're in testing environments, of course, before they're in production, is much less expensive for your organization. The second example, ensuring maintainability and reduced operational expense. This is from a study that was done within Shell, the energy company, in the 1990s. And what they found is that for every 1 hour spent on development peer review, reduced the amount of operational expense or operational maintenance by 30 hours. I mean, what an investment. Can you imagine, if you were able to buy a stock and get a 30x multiple return on your investment? So just significant savings and improvements in terms of, time spent and time saved. But additionally, learning and sharing institutional knowledge. You've got senior developers and junior developers within your team. What better way to make everyone better than by partnering them in a way that implements, the peer review process? It is a great way to build, a great community within your team. So there's a number of different benefits of implementing peer review, which again can allow you to comply with separation of duties, which are required in almost every regulatory framework, and still improve your team and improve your overall product. So there are certainly benefits of complying with those regulatory requirements. I have included the sources for the materials. It's not just my opinion. So this is researched, and I've included all the sources. If you want to download the PDF and dig into this further, please do so. If you're interested in learning more about this topic, there's a lot to review, including Enron the movie. If you want to go ahead and watch that. But I think that concludes everything that I had. So Cody, I will turn it back over to you.
Awesome. Hey, just making sure I'm coming through. Can you hear me?
Yep, we can hear you.
Perfect. Thank you so much. So we have received a couple questions throughout our program. So we're going to take a couple from the top. However, if anyone in our audience does have any lingering questions, feel free to send them in because we're tackling them right now. What is the best practice for production public cloud application reassessment if there are any material changes? I'll go ahead and pop that up on the screen as well.
All right, let me parse this as a long question. So production public cloud applications reassessment if there is any material changes. So a material change, I assume, qualifies as any application change within the system. A reassessment, I assume that applies to an audit reassessment. So in terms of best practices, really, it comes down to making sure you keep track of the who, what, when, where, and why within your application. So, having data retention policies to ensure that you're keeping track and associating requirements that are associated with each and every production release, and proper records of what was performed on that application change throughout the development life cycle that it went through, and then finally the application artifacts themselves after they were deployed to production. That allows you to prove to your regulators, even in public cloud environments, because you build applications typically on developer desktops or within development IDEs. That allows you to prove that chain of custody, the creation of those requirements, and what was actually deployed, and that there's a linkage between all of those things. So it allows you to prove those things. So, ultimately keeping track of what you did for as long as the regulation that you fall under requires.
Thank you, Jonathan. Our next question is, what are some key metrics for measuring software quality improvement, and how can HCL help with the metrics acquisition and analysis process?
Sure, I can take this one. So there's a number of different frameworks for measuring software quality and sort of tracking improvements, because it's one thing to have a dashboard, it's another to actually manage a team to make improvements. One that's well known is the DORA metrics framework. The DORA metrics framework, it comes from a study or studies that were done. It's over 10 years old now. It's now controlled by Google. And basically, the key metrics that they track are, the change fail rate, how frequently when you deploy, is there an issue with your application or with the deployment itself? What's the lead time to make a change to your application? What is the frequency that you are deploying to a production environment? And then finally, the mean time to restore when there is an application outage or impairment. So that's, just four metrics examples that come from the DORA framework. There's also the FLOW framework, which is, you can read more about at flowframework.org. Has some great information, is more focused on tracking business value that your teams can use to really keep sight of the value of the software changes you're making. And then finally, the SPACE framework by Dr. Nicole Forsgren is one of the key people behind that. And that has to do with sort of the correlation between software quality and the overall happiness of the team as a sort of proxy metric for how well that team is performing, typically should produce higher quality software. So those are three metrics frameworks and some of the things that you should keep an eye on. And I would add, HCL Accelerate actually tracks many of these metrics out of the box. So if you're looking to manage your team to make improvements, I think we can help.
Wonderful. Thank you, Jonathan. So right now I'm seeing a slowing question. So I do have one that I've come up with. And so we've been talking a lot about high compliance, highly regulated environments, but what are maybe some key takeaways that people in non-highly regulated environments could take from these regulated industries?
Yeah, I can tackle that one. I think what's interesting is that in a lot of cases, sort of the same process, the same rule sets apply, right? So if we've created controls that are both best practices, which everyone should want to adhere to, as well as regulatory controls that add value to what the software team is doing, there's nuggets of goodness in the framework for everyone. But it really all comes down to your business imperative. The applications that your teams are producing should conform to the business imperative to your overall organization. I used to tell people you would not develop an ATM in the same way that you would develop a derivatives trading platform. One needs to move really fast and hopefully not break things, and one needs to be ultra secure and stable. So you match those business imperatives with how your team develops software, how frequently you release, your tolerance for risk, all of those factors. So there are nuggets of goodness in the framework for everybody, even if you don't have to prove your compliance with regulation.
Wonderful, guys. I really appreciate you taking the time to join us here on Techstrong Learning. And I did just want to give each of you the opportunity to leave us with any final nuggets or bits of information that you'd like to bestow upon our audience. So if you've got one tip or one thing that you would recommend for our audience here, what would that be? Suren?
Practice more DevOps. Yeah, I mean, we see a lot of challenges that people are facing today. So having those practices and understanding how DevOps works helps organizations to do their things much faster. They can deliver their applications much faster with more quality, more security, and all that. So yeah, that would be my one piece of advice.
Cody, what I would say is don't give up hope. Don't jump off the bridge, right? I mean, it's there are ways in which we can, there are people breaking down doors in this industry within different practices that can help us do awesome things, build great things. You don't have to work for a unicorn company if you want to be part of a great organization. You don't have to, it doesn't have to be soul crushing, right? To work in a big, large, highly regulated enterprise. There are ways in which we can develop cool software, develop cool applications, work on great teams, and still be in a highly regulated industry that has a lot of different regulation. Hopefully take the PDF download that shows some of these patterns, take it to your internal audit group and say, let's work together. Let's build a regulatory framework that we can use together that makes sense, that can help us beat our competitors, build the best products that we possibly can, and still be able to pass with flying colors when we face audits.
Jonathan, Suren, thank you both so much. Like Jonathan touched on with those additional resources that we have, they are in the handout section, so feel free to jump over and grab those before we close things out. Suren, you've come off mute. You have anything else you'd like to add?
No, I just wanted to thank.
Perfect. Well, thank you both so much for joining us today.
Yeah.
Cody, thanks very much for the opportunity to present. This has been great.
Of course,
yes.
Of course.
So
to our audience today, I'd like to remind everyone that we have been recording our session. So if you happen to miss any of it, maybe you joined us late, perhaps you'd like to rewatch, you will be receiving an email with a link to access the recording of today's conversation, or you can also find it living on the DevOps website. Just visit devops.com/webinars, and it will be in the on-demand section waiting for you. The 4 winners of our $25 Amazon gift card drawing, they are Arnaud B, Debjyoti M, Mohana N, and Mauricio M. So to our 4 winners, look out for an email from me coming soon. If you don't happen to see an email from me, check your spam folder just in case it happens to be filtered out. I'll be contacting you shortly. I'd like to thank HCL Software for sponsoring our program today. And to our audience, once again, thank you so much for being here with us for the entirety of our program. I do have a link pinned to the top of the chat to our survey, but if you stick around until we close things out officially, you'll be funneled there. And we would love to hear your thoughts about our program today, or if you have recommendations for future topics, please let us know there. Either way, we do hope to see everyone at a future Techstrong learning experience. Have a great rest of your day, and you may now disconnect. Thank you again, Jonathan and Suren.